Hello, welcome. Come on in, find a seat. We'll get started here at the top of the hour. Welcome, everybody. We'll get started here very shortly. Okay, fantastic. It is the top of the hour. Welcome. My name is Alan Barr with COEH Northern California, and on behalf of the NIOSH-supported education and research centers throughout the country, we're pleased to present the 2023 ERC Ergonomics webinar series, where we offer free monthly webinars on various topics on human factors and ergonomics. This collaborative effort on behalf of each ERC's continuing education program aspires to provide access to current research supported through NIOSH ERC programs. Thank you for joining us today. All participants who logged in with their registration email will receive a link to an evaluation form that will qualify participants for a certificate of completion worth 1 continuing education contact hour. We have a couple of webinars coming up on May 17th, the impact of precarious work and psychosocial stress on physical and mental health of California janitors. Then on the 24th, May 24th, California Labor Lab webinar supporting healthy work, law and regulation. You can register for that webinar and other upcoming webinars at coeh.berkeley.edu/webinars. That's coeh.berkeley.edu/webinars. For today's webinar, you'll be muted during the presentation. If you'd like to ask questions, please enter them into the online Q&A, and we'll save some time at the end of the presentation to address your questions. We do encourage you to do so. Excuse me. Today's webinar is being recorded and will be made available along with past webinars on the COEH Northern California YouTube channel. Please take a moment to like and subscribe to our channel to help us continue to grow it. Today's webinar is titled Job Rotation, Considerations for Preventing Musculoskeletal Disorders. And we have 2 speakers today. I'm going to let them introduce themselves. First is Dr. Mark Schall, and also speaking today is Dr. Alexander Vinel. Gentlemen, please take it away.
Yes, thank you. Thank you, Alan. Good afternoon, everyone, or late morning, depending on where you are. Thank you so much for taking the time to attend our webinar today on the topic of job rotation. As Alan mentioned, my name is Mark Schall. I am an associate professor of industrial and systems engineering at Auburn University, where I also direct our Center for Occupational Safety, Ergonomics, and Injury Prevention. I'm a faculty member in the Deep South Center for Occupational Health and Safety. It's one of the NIOSH Education and Research Centers, and I'm happy to be here speaking with you today. Alex, would you like to introduce yourself?
Sure. I am Alex Vinel. I am also with Industrial and Systems Engineering Department at Auburn. I'm also faculty there. I am not affiliated, technically not affiliated with the Deep South Center, but I'm happy to collaborate on some of the research efforts that the center has.
Right. So before we get started today, I need to make some acknowledgments and disclose or not disclose a few things. So as far as acknowledgments, the work that we will be presenting today was supported in part by research funding from the Centers for Disease Control and Prevention, the National Institute for Occupational Safety and Health, and that was through the Deep South Center for Occupational Health and Safety, which is awarded to the University of Alabama, Birmingham, and Auburn University. The findings and conclusions of those of the authors do not necessarily represent the views of the CDC or NIOSH. I would also like to acknowledge our co-authors, Drs. Amir Medizadeh, Sean Gallagher, Richard Sessick, and Kwang Hu. We have no financial interests or relationships to disclose. Our objectives today for this webinar is we ideally want the attendees to leave being able to define job rotation and summarize some of its potential advantages and disadvantages. And then we'd like our attendees to be able to come away being able to describe an optimization framework that we've developed here at Auburn for evaluating the effectiveness of job rotation schemes, particularly as they relate to the prevention of work-related musculoskeletal disorders. So to begin, we'll start high level. So what is job rotation? Job rotation is an organizational strategy that really was popularized in the 1980s and 90s that involves alternating workers between different work tasks that ideally require different skills and responsibilities to achieve different organizational objectives. Now, over time, job rotation has morphed into a common strategy for rotating workers through demanding tasks to ideally more fairly distribute exposure to risk factors associated with work-related injuries and illnesses such as work-related MSDs or musculoskeletal disorders. Now, because job rotation is often used to distribute exposure to risk factors associated with work-related injuries and illnesses, it is a classic example of what would be considered an administrative control in the hierarchy of controls. So, you know, the typical hierarchy of controls, we ideally want to eliminate, substitute, or engineer a control to isolate workers from a hazard. If those things are not possible, then we can implement an administrative control such as job rotation and ideally still provide some level of prevention or mediation from those risk factors. So as a function of job rotation, there's a number of potential advantages that we can see. So one is cross-training. So if we have workers engaging in different tasks across an organization, they're obviously going to be developing different skills that will ideally make the organization more resilient to any challenges that may arise. In addition to that, not only will they become cross-trained and have the ability to execute different tasks, but they'll also develop a deeper understanding of the different work processes that occur in the organization, a better idea of possibly some of the decisions that are being made at an administrative level, and ultimately have a better understanding of the organization in total. Another advantage or potential advantage of job rotation is we can see where employees tend to work best. So by having them rotate through different workstations or work tasks, we can see where their unique talents may exist and ideally identify how they can be working at their optimum. And one obvious potential advantage is that the job rotation can help reduce monotony and boredom and increase overall worker satisfaction, which is a positive for the organization. Happy workers tend to be more productive, and that only will serve the organization well. And then another potential advantage is the innovation that can arise from the new experiences and skills that the workforce develops as a function of rotating through different work tasks. So as workers develop different skills, as they develop a deeper understanding of the work processes, those workers start to maybe see potential ways that they can improve the work. And again, workers tend to be the experts on their jobs, right? So through that development of their skills and sharing of information, many organizations see new innovations that can really be beneficial to the company. Now, having said that, there are some potential disadvantages to job rotation in a general sense. One, obviously, job rotation can be costly and time consuming. If you think about workers rotating through jobs that require different responsibilities and ideally different engagement of different segments of its physical work or what have you. There's likely going to be some physical moving throughout the organization, some time spent doing that. There might be changing of PPE or personal protective equipment. So there can be a cost, which again might seem small, but if all of your workers are rotating, that can add up very quickly. Additionally, there can be temporary reductions to product quality and the overall productivity of the workforce as these employees develop their skills in new tasks. Some work organizations, it can be very challenging to implement job rotation schemes. So for example, if we have workers with specialized skills, maybe those that are typically doing maintenance related tasks where some workers might not have any experience at all doing certain things, say welding, for example, can be very challenging to rotate those workers when they've got those specialized skills and they're needed for those skills. And in addition to that, some organizations obviously have work environments where it can be very challenging to rotate workers or move workers through different environments for various reasons. So maybe it's a manufacturing environment where they're running short production runs, and having workers change through when there's these short runs can be very difficult. Or if you think about maybe like a food processing environment where certain areas of the plant, the workers need to stay in those areas and can't move to other areas because of different hazards to not only the worker but also to the product itself. So those are some potential disadvantages. And then finally, in some work environments, I think about seniority-related job choice as a potential issue for workers in terms of rotation. Right? Some workers might not be interested in rotating. They've worked their way up through the system. They have a senior level position that is a very desirable job, and maybe they don't want to be switching into other work. And so you can have some disgruntled employees. Now, through these different advantages and disadvantages I've mentioned, I haven't really spoken much directly about how this can affect exposure to musculoskeletal disorder risk factors. Job rotation is frequently recommended as a means to, again, potentially vary and thereby reduce the risk over time to these MSD risk factors. The question that a lot of folks ask me as an ergonomist is, well, does it work? Right? Does job rotation have any evidence behind it suggesting that it will reduce exposure to MSD risk factors and ultimately help prevent against musculoskeletal disorders? So in the next few slides, I'm going to go through a couple of systematic reviews or meta-analyses that have been published in recent years. We'll start first with the Padula et al. Paper that focused on manufacturing industries, because manufacturing is a very common setting or environment where job rotation is considered. Now, this article examined studies on job rotation. There were a number of different study designs, a number of different job rotation strategies that were included, and of course, different outcome measures. In total, the authors included 14 studies that they considered in their analyses. 11 of these were cross-sectional in nature, meaning that the exposure and the outcome were measured at the same time period. There were also 3 longitudinal designs. There were 2 non-randomized controlled trials and 1 case control study. According to the authors, the methodological quality of the studies, there was 1 that was considered good, 6 fair, and 7 poor, according to the criteria that they were using. If we look at some of the results from some of these studies, we'll see that the case control study in particular reported that a lack of job rotation was associated with an increased risk of carpal tunnel syndrome. So if we are thinking about in terms of job rotation, is this a good or a bad thing? That'd be a plus in the corner for job rotation. There was a non-randomized controlled trial that reported a significant reduction in MSDs and work absence with group perform rotation. So again, this would be another positive for job rotation. On the other hand, one of the non-randomized controlled trials reported significant increases in low back symptoms with rotation, and also the employee's perception of the exertion related with their work tasks. So that would be a con. And then there were several studies which did not show statistically significant or practically meaningful effects. So we'll kind of consider that not a positive, not a negative. More research needing to be conducted. So ultimately, the authors of this paper came to the conclusion that there was currently weak evidence supporting job rotation as a strategy for the prevention and control of musculoskeletal disorders. In particular, they found that job rotation did not appear to reduce the exposure of physical risk factors, although there were some of these positive correlations between job rotation and job satisfaction that we discussed as a potential advantage of job rotation. And again, this was a study that was focusing on manufacturing work. So, and a few years before that, in 2015, Leiter and colleagues conducted another systematic review. They were looking at various industries. And I'm not going to go through all the details of their study, but overall, they included 8 field studies and 3 laboratory studies that they considered of sufficient quality to be included. And in general, what they found was that there was inconsistent evidence for a positive or negative effect of job rotation on musculoskeletal complaints and exposures related to those musculoskeletal complaints. So that's 2 systematic reviews in the last 10 years that have shown either, again, inconsistent or weak evidence of job rotation being an effective intervention for musculoskeletal complaints and exposures. Finally, there was most recently in 2021, Malekis and Meyer completed a meta-analysis. So basically a study of other studies. And in their 3-level meta-analysis that included 56 studies and almost 285,000 people, they showed that there were positive relationships between rotation and physical health only when rotation was compared to high intensity work. Right? So ultimately, the question, to give an answer, does it work? My argument would be at this time, it seems that there's inconsistent findings. And the question is, why are there these inconsistent findings for what conceptually would appear or seem to be a reasonable idea? Right? Why do we see these results? Well, I think there's several potential issues to consider, and others that have written about the topic have identified these as well. Obviously, job rotation and the actual implementation of job rotation can be complicated, right? There are different ways that we can rotate workers based on how many hours they spend at each workstation. Are they doing a true job rotation, changing jobs maybe day to day, or are they doing a task-based rotation? Are the rotations actually stressing different body regions, or are we just moving workers, a position or 2 down the line, and they're still being exposed to the same physical risk factors? Again, there's a lot of variability in different job rotation strategies, and that can complicate things. In addition to that, there is a lot of inconsistent designs of the studies that have been conducted. And in the outcome measures that are used to evaluate if a job rotation scheme is being effective. So, this again can lead to this potential inconsistent finding. Finally, there have been some that have argued that we currently lack appropriate tools and metrics to actually evaluate the diversity of exposure. And where we want to talk about next, and what I'm going to transition to Alex with, is that many of the risk assessment tools that we use to assess physical risk factors assume that risk is additive. And that may be one of the factors that leads to why we are seeing these inconsistent results for job rotation. So what I'm going to do next is turn it over to Alex, and he's going to talk to you a little bit about how we've used some of this risk as additive concept to examine job rotation using an optimization framework.
All right. Yeah, thank you, Mark. So yeah, I'm going to take over from here and talk about some of the particulars of the research effort, some of the observations and conclusions that kind of informing the big picture message and the conclusions that Mark is going to come back and kind of give at the end to wrap it up. All right, so I personally come from the operations research side of industrial engineering. So kind of my role in this effort was mostly on the optimization side. So I'm going to talk about that, but I'm kind of trying here not to assume too much of their kind of pre-consistent background knowledge in that. So I'm going to start with a very brief, if I can make this work, there you go, very brief overview of kind of mathematical optimization in general, as much as it applies to the topic here, and then get back to the rotation and kind of how we think about it. So kind of all said and done, mathematical optimization is a science of how to formulate and solve decision-making problems that have to do with selecting between a potential set of options. Now, specifically, this only applies when we have a lot of these options, so usually infinitely many, or at least some kind of combinatorial number. And all of the components need to be expressed as mathematical expressions, right? So the main components typically are, you have decision variables that usually, in standard linear programming and all of that is production levels, route schedules, or assignment of workers to jobs. In our case, we have objective function that tells us how good or bad particular decision is. And then we have constraint functions that tell us whether particular decision is feasible, applicable, or possible, right? So all of that comes together into kind of one big or series of mathematical problems. And our role here is to talk through how to formulate this kind of problems, what kind of formulation makes sense, and how to ultimately solve them. Now, within the context of rotation, oops, there it is. Within the context of rotation, again, we're obviously not the first ones to notice this, that designing a rotation is just an example of a very typical optimization problem, right? So here we have a collection of jobs and workers. We want to determine what each worker does, or which job each worker performs at any period of time. We have some constraints that have to do with qualifications, shifts, logistics, whatever that is. And then importantly, we need an objective right now. As Mark was saying, there are multiple different reasons why one might want to engage in a job rotation. So specifically here, we're talking about thinking of job rotation as a way to reduce musculoskeletal disorder risk. So within this context and some of the same literature that we talked about earlier, kind of a typical structure for optimization problem for job rotation is you pick an evaluation method, right? So these are your ruler, Okra, Reba, whatever you like. You usually concentrate on maximum exposure, right? So the goal here is to reduce the risk associated with the most exposed workers. So you construct it as a minimization problem where the objective is to minimize the maximum exposure among your worker population. And then after that, this is just a standard schedule and assignment problem, which is very much prominent in the operations research literature. Now, importantly, and kind of re-emphasizing something that Mark said earlier, is most of literature assumes that risk is additive, right? Now, what does that mean? Here, we're talking about a rotation, which means that what we're really looking for is a worker who performs a series of tasks, one after the other. And then the question is, we may be able to evaluate the risk associated with each individual segment with our preferred evaluation method. But then how do you combine those individual segments into an assessment of the whole shift? And additive assumption means that we just add those risks together, and that gives us the kind of the total score for the assignment. Now, within this framework, it is always true that a rotation is going to be a good idea, right? So if we assume that we can take a hard job, split it in half, and give those halves to two individual workers, and they're going to get half of the risk, well, then obviously, from the perspective of reducing the total exposure, doing that rotation is going to be good, right? And if that's the case, we can immediately follow through to the question of how to do the rotation. And there are quite a few papers in the literature that propose different versions of practical job rotation strategies that have to do with, satisfying some particular constraints that have to do with how you want to structure your shifts, whether you want to rotate every hour or every day or whatever that is. So our effort here and our research question is try to slow down for a moment and say, okay, if we don't assume and if we don't make this additive assumption, and specifically if we think that risk actually is not additive, what kind of effect it has on the very question of, does rotation make sense before we get to the practical design, right? This kind of a summary of our research question as we formulate here. So specifically, we're going to base the analysis on fatigue failure model for musculoskeletal disorder development, and I'll talk about fatigue failure model. In a moment. But essentially, our goal here is to try to come up with a simplified mathematical optimization model, such that we can still make such that we can make some analytical conclusions, right? So I want to kind of re-emphasize here that our goal is not to try to design a tool to propose practical rotation strategies, and instead try to analyze the principle of, does rotation even make sense, given what we believe we know about how MSDs develop. All right, so on the fatigue failure model, right? So this is a well-established risk assessment tool that has not too long ago been developed at the occupational safety group here at Auburn, and there are different ways one could think about it, but essentially the way I'm gonna use it for the purposes of this talk is kind of flowing from three main pillars, right? So first, we assume that materials fail as a result of damage accumulation. Now, that damage accumulation is going to be added, right? So if you have a task that consists of a number of cycles, then the total cumulative damage from that task scales linearly with the number of cycles you perform, right? In other words, each additional cycle brings additional cumulative damage. Now, on the other hand, the way that damage is related to the actual negative health outcomes is going to be nonlinear, right? So we posit that there is a nonlinear functional relationship between the total damage and the probability of a negative outcome or a risk of a negative outcome. And then there's been an extensive amount of work done, try to design experiments, look at historical data, observational studies, and all of that to try to quantify what exactly that the relationship looks like, validate that, and all of that, right? So for the purposes of our conversation here, we take all of that as a given. And I think I'm going to skip this and kind of go straight to the functional relationship, where for our purposes, we're going to assume that fatigue failure theory tells us the following. If we have a task, what we need to do, or collection of tasks that are performed together during a shift, what we need to do is to count the total cumulative estimated damage for that task. That's going to be our Y. Then we take values A and P, which are parameters that need to be estimated from the data. And then the outcome of this model is F of Y, which gives us the probability of a negative health outcome, or as a MS musculoskeletal disorder risk that we can use as the objective for our problem. So importantly for our purposes, the shape of this relationship is this kind of concave curve, where on the x-axis we have cumulative damage, on the y-axis we have the probability, so F of Y. And as you start performing cycles of a job, you continue accumulating damage. First, you very quickly accumulate probability, but the rate of that accumulation slows down as you get to more cycles performed. And again, this is just what follows from the fatigue failure theory as proposed and described earlier. All right, so with that, what does the rotation look like if we think about it from the fatigue failure perspective? So here, this is just kind of an illustrative example. Let's say we have 10 jobs, and these 10 green squares correspond to 10 workers performing those individual jobs without any rotation, right? So each worker has their own column, And then on the y-axis, we plot the f of y, which is our injury probability. So in this pool, we have one worker who's at about 25%. We have a couple of workers that are about 45, and kind of some workers in between. So what does the rotation mean? We would take some of this hardest job, for example, for worker number 10, give it to worker number 1, and instead take some of the job that used to be done by worker number 1, give it to worker number 10. Obviously, that would mean that now worker number 10 faces less cumulative damage, which reduces their probability. Worker number 1 is going to have to deal with more damage, which is going to increase their probability. And then we have a lot of these options for how we can mix and match these tasks, and maybe we can come up with different forms of rotation. Now, important observation here is that the only way we can make the most exposed worker better is by giving away some of their tasks, and then whoever has to pick up those tasks is going to have to be faced with additional damage, which means that there is intrinsically a trade-off. Right now, in this example, right, so if we think of a blue line as one of the rotation that is possible, here we would see that, okay, these 3 workers, so number 8, 9, and 10, are somewhat better off, right? So their risk has decreased. These 2 workers, 1 and 2, will see some increase in their injury probability. And then overall, the question here is, okay, does this trade-off, like, first of all, there's always going to be a trade-off, but then the question is, does this trade-off make sense? Is it worth it? And what does that even mean, right? So this is really kind of the question that we're trying to answer by trying to think, okay, what are the possible rotation strategies, and what can we say about the outcomes of these rotations? So here's how we think about designing a rotation. The next couple slides talk through the formulation. I'm not going to go too deep into that at all. You know, all of the details we can kind of discuss in the Q&A, and I'm happy to answer any questions on that. But kind of the really kind of the most relevant part that I think is worth taking out of it is that the way we think about rotation here is, again, I'm going to reemphasize that we abstract away from a lot of the practical consideration of, like, for example, scheduling a sequence of tasks, thinking about breaks or anything like that, right? From our perspective, each job consists of a number of cycles that need to be performed. And all we're doing is we are assigning how many cycles of each job each worker is going to have to do. Then we carefully keep track of all of their fatigue failure implications and all of that, and arrives at one nice big optimization problem. Again, the details here are not terribly important. What is important is that we can kind of mix and match different goals for how we specifically want to approach the question of what is a good rotation. So as I mentioned, typically in the literature, you would focus on the worst assignment, right? So specifically, you would minimize the risk faced by the most exposed worker, and we're going to refer to this rotation as minimax rotation. Similarly, instead, you could focus on the average risk, right? So you could say, let's minimize the average risk faced by all of our workers. And if we interpret the risk as probability, that would also minimize the expected number of injuries that we will observe under this assumption. And then finally, we can think of trying to maximize diversity of assignments, right? So for example, if we split each job into equal pieces and give each worker one piece of each job, that would maximize the diversity of assignments. All workers would have the same assignments, would be faced with the same risk, and that seems like a reasonable way to go about rotation. All right, so again, the reason why we do all of this simplification is so that we can make very precise statements without kind of trying to without really need to make assumptions on, okay, what exactly the jobs are and anything like that, right? So here are some results that we can here are some claims that we can make that follow directly from the formulation itself, right? So again, to emphasize here that this is a result that is an immediate consequence of the formulation itself and does not really have to do with any particular instance of the problem, right? So I think most important one, and the one I'm only going to talk about here, is our claim number 3, which says that if we assume the fatigue failure theory, we already saw that there's going to have to be a trade-off between the amount of improvement that we observe for some of the workers weighted against the amount of an additional risk that's going to have to be taken by some of the previously less exposed workers. So what we can show is that under fatigue failure theory, it is actually impossible to design a rotation that does not result in an increase in the average risk exposure for the worker pool, right? So in other words, no matter what we do in terms of a rotation, this trade-off is always going to be negative, right? And the reason why that happens kind of intuitively is because of that concave structure of their risk profile, right? Where if you're already pretty high up in the curve, in order for you to reduce the risk significantly, you're going to have to give away the big chunks of that job, which if that job is given now to a previously less exposed worker, they're going to now be faced start early on in the curve, which this is where this kind of mismatch in the trade-off comes in. So two things I want to add to this, right? So first of all, this is we show this under fatigue failure theory, but in fact that as a mathematical fact, it holds for any risk assessment approach, as long as it has to do with their concave risk function, right? So even if we don't want to stick strictly to the fatigue failure theory, for somewhat wide range of different approaches, as long as the risk function is concave or even if linear, this result still holds. And secondly, it does not limit our conclusion. The fact that we have assumed away a lot of these practical considerations on, for example, you don't want to rotate the worker, I don't know, every minute, right? Obviously, each worker can only do so many tasks during the day. None of that, the fact that we do not consider this practical consideration doesn't really limit the conclusion itself, right? The conclusion itself holds for all possible rotations. This includes the ones that would be practical under a particular regime and particular working conditions that we have. All right, so this is kind of analytical, theoretical result that we show holds for our model. So let's kind of talk a little bit about what does that mean on a slightly more tangible example. So as a way to illustrate how this works, we do an illustrative case study. So we take two data sets that have been previously used essentially to design the fatigue failure model. They both have a couple hundred jobs. We have values of cumulative damage for those jobs recorded. They have their own distributions of injury probability, and then we split them into separate classes to enable us to sample different job collections with different risk profiles. So what then we're going to do is we randomly sample 10 jobs from these sets. We make sure that we sample in an intelligent way so that we get different kinds of profiles in this each 10 job collection. And then we think of these two jobs as, let's say these are the 10 jobs that we have. What happens if we perform a rotation on these 10 jobs? Now, we know from the theoretical result that the trade-off is always going to be not in our favor. So what we're going to report on these rotations is two measures of how bad that trade-off is working out. So average increased probability per worker is just how much the average worker, how much of increased risk does an average worker see? And then efficiency ratio is just the total improvement divided by the total worsening. So for average increased probability, obviously 0 is good, positive is bad. For efficiency ratio, 1 is good because total improvement is equal to the total worsening. 0 is bad. That just means total improvement is a small fraction of the total worsening. All right, so first two particular examples. So the one on the right is the one we've seen before. So here we have a kind of a moderate a collection of jobs that are kind of moderate in terms of total risk, right? So our least risky job is about 25. Our most risky job is about 45. And then the blue line here, the min-max rotation is if we try really hard and make sure that the most exposed worker is as good off as the best off as possible. So we see here that we are able to improve the conditions for some workers. It does come at a price of worsening conditions for some other workers, but overall the trade-off kind of sort of makes sense, right? So we improve conditions for these 5 workers, we worsen conditions for these 2, and then these 3 are kind of about the same as they were before. That overall kind of makes sense, not terribly bad. Picture on the right? So here we have 2 jobs that from the initial pool that were really bad, right? So these are both in the 90s, and these were very bad damaging jobs. So if we want to take these two workers, number 9 and number 10, and make their conditions better, the only way to do that is to take some chunks of these jobs and give it to the workers number 1, 2, 3, 4, and 5. As soon as we do that, now they're faced with the damage associated with those jobs, and then very quickly, because these were very damaging jobs to begin with, we get to a situation where, well, the best thing we can do is to give everybody an assignment that is about 85% risk. Now here, this is kind of where kind of the most dramatic version of this trade-off that I was talking about, right? So we made 2 people better off a little bit at the cost of really significantly reducing the quality of jobs for the other 6 people. Now, we do this sampling, so we sample a bunch of different profiles to see kind of what makes this work or not, and kind of I'm not going to go into the details of these plots for the sake of time, but essentially the conclusion here is that even if the job pool that we have has a single or a couple of jobs that have score very high on the damage spectrum, right? So if the maximum probability of the jobs in the pool is high, right? So say, for example, in the 90s, on average, we see what sort of it's about 13% increase of risk for all workers, right? So again, this is kind of just saying that you can improve the conditions for the worker that would do the hardest job, but that comes at an increased risk associated with all of the rest workers in the pool. All right, so before we get back to kind of the big picture view, some immediate conclusions from the study itself, right? So again, the study obviously is limited by the assumptions that we have made and by the way we have constructed this study, but the goal here really is to illustrate the idea that the reason why any kind of rotation would have a positive effect on some workers' musculoskeletal disorder development is because some other workers would have to do parts of that job, right? And under the assumption of fatigue failure theory, which is what we think makes sense in this case, any gain in this efficiency is always going to be guaranteed to be smaller than the absolute value compared to the losses faced by the other workers, right? So there is a natural trade-off here, and at least as far as this kind of analysis goes, this trade-off is always going to be not in the favor of average improvement. That said, obviously it does improve the worst conditions in the pool, and whether or not it's ultimately worth it is really kind of the question of what kind of goal we are pursuing specifically. All right, so with this, I think this is where I turn back to Mark.
Yes. All right. Thank you, Alex. So implications. So what does this mean for us, right? As occupational safety and health practitioners, ergonomists, so on and so forth. Ultimately, introducing that variation by rotating workers with different demands can actually lead to an overall increase in risk, right? So I think while job rotation has its potential advantages, I think this really underlines or underscores the need to really focus on keeping at that top of that hierarchy of controls and focus on redesigning work so that we are eliminating, substituting, or controlling hazard. And what I would recommend, or what I teach my students here at Auburn to do is kind of these couple of things. One, we definitely want to make sure we're analyzing more than just a snapshot. We want to be leveraging emerging objective technologies. Want to involve our workers, and we want to adapt continuous improvement strategies as best we can. So let's talk about each one of these, right? So analyzing more than a snapshot. There it is. All right. So with regard to analyzing more than a snapshot, I think it's important not to oversimplify risk assessment. Right? Conceptually, I think many people understand that risk is not additive. If you take the example of bending down to lift a box, we all inherently know I can get injured by bending. I can get injured by holding a box in front of me, but the risk certainly increases, and not necessarily linearly, when I bend and lift as part of that dynamic action, right? I mean, we all engage in these different activities and understand how bending over and lifting up a heavy box, and through that dynamic action can place us at greater risk for developing that. And I think that's because we know that risk factors are often interactive, right? High force and high repetition has a greater likelihood of leading to a musculoskeletal disorder than just doing one or the other, right? So those interactive risk factors need to be considered, and to do that, I think you need to analyze more than a snapshot. Checklists, although they have their place and they can be very valuable in a lot of organizational settings for determining where we want to prioritize our risk assessments. I don't think a checklist is sufficient for evaluating risk, and I don't think a lot of tools that are based on some of these linear concepts are necessarily sufficient for evaluating a cumulative risk. Right? Job analysis really should consider those variable demands that we place on our body over time, right? And that's multiple body segments, not just the demands on one particular body segment. So how do we analyze more than just a snapshot? Well, in my opinion, we need to leverage emerging objective technology. So I'm a little biased in this, in that a lot of my research deals with how can we apply wearable technologies to improve exposure assessment practices. But as time goes on, a lot of the tools that we've been researching the last 10, 15 years are becoming more and more prevalent, and there are more and more companies that are providing ways to make cumulative assessments through objective means. So whether that be a wearable inertial measurement unit sensor that you can wear on your body in the right, or as shown on the right, or whether that be a computer vision based solution where you can show your iPhone camera or other smart device camera on a worker, and computer vision can look at the kinematics that worker is being exposed to. The idea is that these are going to be more objective than our standard assessments if we're completing them through an observational means. That doesn't mean that there's no place for observational assessments. I think there are, but we definitely want to be leveraging some of these emerging technologies to support what our intuitive assessments and what our observational assessments are telling us. As far as involving the workers, participatory ergonomics. There's research in its own right on participatory ergonomics, and I'm not going to go into a lot of detail on it, but I do think that there is a place for actively involving our workers and having the actual experts at the different tasks that are being conducted in our facilities to develop and implement workplace changes and identifying solutions. Now, how to do that? There's a number of resources out there that provide some guidance. I think some of the basic, fundamentals to it. We definitely want to involve, create teams of workers involving employees at all levels of an organization. That includes our senior management, our supervisors, our specialists, whether that be an ergonomist or an occupational health nurse or whoever that might be. We want to include all those folks along with our production workers to try to solve problems together. We want to gain management buy-in, and I think we can gain their buy-in by having those senior managers involved in these processes so that they can hear back from the workers what they're experiencing and hopefully reduce some of the barriers that many companies see when it comes to implementing changes that should are designed to improve the worker health and safety. Identifying a site champion, right? So this doesn't necessarily need to be an ergonomist, but somebody with the requisite knowledge and leadership capabilities to facilitate this work group, I think is really critical. We want to make sure we establish clear responsibilities and have everybody involved to own that process. By assigning responsibilities to members of our participatory ergonomics teams, everybody has that sense of ownership and becomes more engaged in the process. And ultimately, I think that will lead to better outcomes. We want to provide ergonomics training to everybody involved. Some of these again, we'll call them participatory ergonomics teams, but they go by other names, or they can go by other names in different organizations. We still want to make sure we're providing that training so everybody has a common, skill set to refer back to when we're talking about the changes and the improvements that we can make in our facilities. Not only do we want to obviously involve workers from all levels of an organization, but we want to make decisions as a group. And that again will initiate or facilitate buy-in across the organization. And then finally, encouraging open and consistent communication among all team members. I've been part of a number of research teams that have worked at establishing participatory ergonomics. And one of the biggest challenges that often comes up is as time goes on, there are shifting demands in the organization. And oftentimes that communication can start to break down. And we really need to make sure we've got those leaders in place that can continually encourage that communication to keep that process moving. Another thing that we can do to involve workers, harness the knowledge that they have as experts, and execute the work that the participatory ergonomics program identifies involves looking at iterative continuous improvement strategies. Right, and so many of these continuous improvement strategies, I've shown two here. One DMAIC, one the Plan, Do, Check, Act or PDCA cycle. These are core fundamental lean engineering philosophies that are been shown to provide a structure to a process, such as a participatory ergonomics process that can lead to benefit. So. I think we definitely want to adopt these continuous improvement strategies where possible. So in the interest of time, I'm going to transition. I just want to point out, resources. I know we talked about a lot of different things today. Particularly, it's a math-heavy topic. The job rotation model, that framework that we were describing. If you'd like more information, the work is published in the Journal of Ergonomics. Feel free to contact me. I'll put my contact information up in a little bit. I'd be happy to share the paper with you. As far as resources, as Dr. Vinel described, we have based a lot of our model on the fatigue failure principles. We do have a number of ergonomic assessment tools available at our website. The easiest way to get there is just aub.ie /OSEIP. That's our center, and you can find all of our tools there. We've got online versions, we've got Excel versions. Again, they're available for your interest. Quickly, our resources. These are some of the papers or websites that we cited throughout. Providing the foundation for the work that we described. And then again, our contact information, you've got email addresses for both myself and Dr. Vinel. So again, we'd be happy to address any questions now, but also if you have questions and you would like to contact us later, please feel free to do so.
Thank you, Mark. Well, let's leave that slide up and people can copy down. I know there are some people that would like to reach out to you. I can already see that in the questions. Akron has already expressed interest in potential collaboration. Thank you very much for a fascinating talk. There's a lot to unpack there, obviously. I'll ask the first question that I think I'm sure I'm not alone in. Should we promote job rotation or not?
Well, like we discussed at the very beginning, I think job rotation certainly has some advantages. I think, again, you can make the workplace, definitely being able to cross-train your workers and sharing the information about the different work tasks that are conducted has a lot of potential advantages. From a musculoskeletal disorder prevention standpoint, unless you're, at least based on the model that we just discussed, and I'll ask Dr. Vinel to, confirm this, but based on, what we've presented, unless you have a workforce that is generally at very low risk, it does not seem to have the benefits that job rotation has often been advertised to provide.
Thank you.
Yeah, I think I can only kind of echo that conclusion, right? I mean, if you have a job and instead of having one person do it, you have two people do it, then yeah, that's obviously good. And from that perspective, if it's not a pure one-to-one where like you just spread stuff around, I mean, that there can be situations where that makes sense, but like their unequivocal no, don't do it conclusion only applies for somewhat narrow from a way of thinking that we have here.
Gotcha. I noticed that and I guess I was somewhat surprised that because I did jotted down a question asking about the risk distribution, what the impact was on overall company-wide risk, and then then the next slide, of course, you answered the question. You said that increases, and so obviously that was sort of a negative outcome. But then it sort of begs the question that the model that you presented, Alex, I didn't see anywhere where it factored in an individual worker's capacity. Some people being more suited or having a greater capacity to perform a task. And so if that was added into the model, do you think that could have some effect?
Yeah, so I mean, that's one of the kind of practical consideration that we kind of try to avoid. So the way we think about workers' jobs is each job consists of a certain number of cycles that need to be performed. And then we just assigning these cycles to workers, and I think for that version, we assume that each worker can perform certain number of cycles total, and that's their total shift. If some workers are like, for example, I don't know, are able to perform certain jobs better in a less risky way, I mean, yes, that's obviously going to be beneficial, right? But I think that's more of a training and being able to use best practices kind of consideration rather than the effect of rotation, right? Like that's
so I'll add in here. So the optimization model is using the fatigue failure risk assessment tools that are currently in place. Those tools are basically built around like a 50th percentile, male doing an activity, right? We certainly are aware that personal characteristics and other risk factors play a role in MSD development. We are currently in the process of developing, updated versions of those tools that will, we hope, incorporate those personal, or at least some personal risk factors, personal characteristics in the models. So that is an excellent question. That's something that I do think is coming down the line. How long it will take is yet to be determined, but we are working on it.
Excellent. Intuitively, it just seems to jump out at me that there should be a benefit. So I'm a little bit disappointed that there's not some overt and positive outcome here, but especially given that it feels like ammo for employers to they can basically say, oh, you're just going to increase my overall risk, so this is I'm not going to consider this further. We have a question came in for you. It says, where is job rotation application more feasible? Is it office work, manufacturing, or construction? And why do you think, if so, why do you think so?
Well, again, based on the model that we presented, assuming, and you got to be very careful with because each environment's different, right? One manufacturing environment might be different than a construction environment. I think if we think about it in terms of generalities, like office work is going to be at lower risk than, say, a physically demanding job, if we're thinking about in terms of physical risk factors. Well, again, if everybody is doing office work and that's maybe a lower probability, well, then that might be beneficial in terms of the model that we presented. But again, it's very hard to say that because every work is going to be kind of unique. Every organization is unique. And so I think what I would advise is that you take the kind of model that we're applying and look at it in your unique situation, your unique scenario, and see how would it work for the risks that are included.
All right, thank you. We are running out of time here. I just have to make some closing comments. If I didn't get to your question, I apologize. You do have the contact information here on the screen. Please feel free to reach out to our presenters directly, as they've been kind enough to offer that. You can learn more and register for our upcoming events at coeh.berkeley.edu. You can also subscribe to our YouTube channel, where you can find recordings of previous webinars and other events. As a reminder, if you logged in today with your registration email, you'll receive a link to an evaluation form that will qualify you for a certificate of completion worth 1 continuing education contact hour. If you have questions in general for us here at COEH Northern California, you can drop us a line at coehce@berkeley.edu. That's coehce@berkeley.edu. And I want to give a big thank you to our presenters today. Gentlemen, do you have any closing comments before we sign off?
I'd like to say thank you so much. Again, if anybody has any questions or would like some further information, feel free to contact us. But we really appreciate you taking the time to hear what we had to say.
Yep, I'm just going to echo the same sentiment. I appreciate the invitation and a very well-run seminar. That was awesome.
Thank you so much. We enjoyed it. We'll talk to you next time. Bye-bye.